A warm welcome to everyone. Thanks for being here today.
TRIQUETRA project employs a holistic approach to safeguard Europe's coastal and underwater cultural heritage from climate change and natural hazards. By integrating risk management, protection, and preparedness strategies, TRIQUETRA aims to prevent damage, identify threats, and promote policy tools for climate neutrality and economic resilience. A multidisciplinary team develops a preventive conservation strategy, including monitoring and risk management, to protect underwater and coastal heritage sites towards adaptation to climate change. Cutting-edge technologies like ICT and Internet of Things are harmonized with social innovations through participatory processes such as citizen science and living labs, creating an integrated heritage risk assessment and protection system. The collaborative efforts and shared strategies discussed during the Green Cluster meeting that took place at EGU General Assembly 2024, which was coordinated by TRIQUETRA project, aim to enhance the effectiveness of EU-funded projects like TRIQUETRA, RescueME, TRIQUETRA, and STECCI by fostering synergy and knowledge exchange among partners. These collaborations enable the integration of diverse expertise and best practices, ensuring comprehensive approaches to address climatic risks and preserve heritage. By aligning goals and methodologies, this project can leverage shared resources, innovative technologies, and policy tools, thereby increasing their impact. Joint initiatives and coordinated actions facilitate more robust risk management, protection, and adaptation strategies, ultimately improving the resilience and sustainability of cultural heritage sites across Europe.
I will say the main challenge is the uniqueness of the cultural landscape. Each cultural landscape is very special because it's facing different hazards, has different vulnerabilities, and also different types of governance, and especially different types of cultural heritage. And that makes that each of the cultural landscape has to find their own path for their resilience, and that makes challenging. I will say the main challenge is the uniqueness of the cultural landscape. Each cultural landscape is very special because it's facing different hazards, has different vulnerabilities, and also different types of governance, and especially different types of cultural heritage. And that makes that each of the cultural landscape has to find their own path for their resilience, and that makes challenging.
How does the RescueME continue to develop the EU and R&I task force for climate neutral and resilient historic urban districts after its creation between the projects ARC, Shelter, and Hyperion?
First, participating in events like this with our the other projects for climate impact team, but also when we were working in the task force, we find a lot of gaps, a lot of needs of research, and we shape with that our RescueME project. So while we are working in this project, also we think that we are working in the recommendation of the first stage of the task force. First, we wanted to be flexible and replicable, introduce an holistic approach, cultural landscape as socio-ecological systems. We wanted to be very heritage-centric, introduce heritage metrics in the assessment and try to quantify it as much as possible, especially the 5 capitals that we have identified within the importance for the cultural landscapes.
First of all, the TRIQUETRA project is a European project which is multidisciplinary and collaborative, involving 7 countries and 21 partners with one common goal: to protect cultural heritage against nature. So how do we do that? Well, we use 3 simple steps. Step 1, we identify the relevant hazard for each site of interest. In step number 2, we explore the effects of these hazards on different types of cultural heritage sites, including rural and urban, coastal landscapes and underwater heritage. And based on that, we can do a precise risk quantification. And in the third step, we develop the tools like a digital platform that also involves a mitigation module that will help decision makers and stakeholders to take proper action. Well, we have 5 groups of tools, I would say. Tool number 1 is a knowledge-based platform that basically gathers relevant data of natural hazard and climate change and cultural heritage from all around the globe. Tool number 2 is that we will develop beyond the state-of-the-art physics-based models that will describe the effects of the natural hazard on cultural heritage. Tool number 3 is that we'll develop sensors, including an in-situ water quality monitoring against chemical hazards, as well as a LiDAR-based 3D scanner for rapid mapping. Number 4, we're also going to develop novel coatings for protection against wetting and deterioration. And finally, a decision support tool for stakeholders.
By combining augmented reality and crowdsourcing, the TETIDA project's mobile application creates a dynamic and interactive platform that fosters deeper community engagement and awareness. Users are not just passive consumers of information, but they are active participants in the preservation of their cultural heritage. The augmented reality features captivate and educate users, while the crowdsourcing elements empower them to contribute to the protection and monitoring of heritage sites. Together, these technologies create a vibrant community of informed and motivated individuals. They are now dedicated to safeguarding Europe's coastal and underwater cultural heritage against the threats posed by climate change and natural hazards.
Working with satellite remote sensing, we found that underwater, especially working with the underwater archaeology and especially with cultural heritage protection, we found recently that using satellite remote sensing, it gives us great advantages into looking and monitoring these sites, and also using different techniques. We found that now with the different sensors, with Sentinel-2, with planet data, and also with aerial images, we'll be able to classify and also monitoring and documenting cultural heritage sites under shallow waters. We apply the remote sensing and satellite remote sensing techniques in the Amathous archaeological site in Cyprus. Amathous was an underwater, right now it used to be a port back in the 300 BC, and now it's about 4 meters underwater. We apply different type of techniques using Sentinel-2, using planet data, 3-meter planet data, and also area images into monitoring and documenting the site of Amathunda. Some of the technical challenges that we face working with the shallow water Amathunda project was the resolution of the images. We found that the higher the resolution that we have, and especially with 3-meter or even with area images of 20 centimeter resolution, it gives better results rather than working with with less resolution with Sentinel-2 images.
Based on my experience in a previous Horizon project, the Hyperion project, I confirmed that remote sensing shows great potential on recording and monitoring climate effects on cultural heritage. Its innovative character stems from its ability to provide quantitative and qualitative information on objects, materials, materials, and phenomena based on the processing of images captured in many spectral bands spanning from visible to thermal infrared. We have nowadays free of charge imagery, satellite imagery, that triggers the processing from individual, the shift from processing from the individual images to time series images. Then it is beneficial, remote sensing is beneficial from artificial intelligence advancements. It's many problems that remote sensing solves have models, physical models that are quite complex and non-linear, and the features, the abstract features that models, artificial deep learning models provide us can simulate efficiently these problems. Finally, we have nowadays upcoming development of analysis-ready data that enable the users from local to go to general and more general and regional general applications. In the project, we intend to create tools for monitoring cultural heritage that is underwater or in marine areas. For this purpose, we explore multispectral remote sensing to map coastal changes and coastal erosion. We use time series differential interferometry to measure the land deformation and permafrost dynamics. We use hyperspectral remote sensing to characterize materials and create deterioration maps. And we use 3D remote sensing to create 3D models in order to analyze the structure of the monuments. We are very passionate about our work. Visit the web page to see our fascinating results.
All materials in different cultural heritage are threatened by different environmental stressors, and the change of climate conditions change also the threaten these materials are exposed. It's hard to say that one specific parameter is more relevant and more increase the risk of the different materials, especially if we consider cultural heritage exposed to such different environmental conditions like the coastal environment and the underwater. There are some common aspects, surely, which are related, for example, to the change of water conditions, pH, and water temperature are surely important factor determining the kinetics of deterioration processes, especially underwater. But climate change also influence the intensity of extreme events, and which are relevant especially for coastal cultural heritage, as well as the intensity of storms, for example, and which accelerate all the processes even related, for example, with salt crystallization, which is a key factor in coastal environments, threatening the buildings which are directly or indirectly exposed to the action of the sea, at the proximity of the sea. So I think that in TETIDA we try to take into account all these different parameters, including even other risks like flood risks and how climate change is influencing flood risk, and apply models which take advantage of sensors that we are going to deploy in the different sites to better evaluate what can be the vulnerability of the different cultural heritage sites in order to be increase our readiness in facing the future deterioration and help in taking actions to protect our common cultural heritage for future generations.
Well, living labs are important multi-stakeholder platforms that bring like the local stakeholders, the citizens, and also the end users together to form kind of like partnerships where they can also function as collaborative decision-making platforms, or they can also be like inclusive processes for co-creating certain solutions to the problems. So it's quite important to have like these kind of inclusive and participatory processes, because also risk monitoring, risk assessment, they need valuable insights from the end users and stakeholders that can actually help identify additional threats or additional impacts, what people value about these places. So it's really important to integrate their reviews. And within the TETIDA project, actually, we are employing the living labs in order to bring people together and to function as a collaborative decision making. And it actually undertakes like 4 different tasks. So it's important to assess, what are the values of the pilot sites, what are the impacts, actually the more larger cumulative impacts regarding it, and also to co-create like future scenarios and build some roadmaps for active monitoring of the sites. That's how we use the living labs for this.
It is important to bring different perspectives because practical challenges or actually are rooted in different expectations or mindsets on what it's what a project is about, what the cultural heritage should be, what a policy it's aiming to do. And in these levels of maybe oppositions, contradictions, or different goals and aims, that's where practical problems arise. So living labs are about creating the spaces where our partners can actually discuss what could be a challenge, either from implementing the monitoring tools to actually bring our results to have a bigger impact.
RescueME uses co-creation in 2 different forms and involves 2 different kinds of stakeholders. First, we have our resilience labscapes, our cultural landscape pilot cases, where we co-create, co-develop and validate all our solutions across 5 different sites in Europe. And these sites have different hazards, different sizes, different stakeholders, and also different heritage types. And within or across all of these cases, we can compare our solution, and then therefore it's more general applicable. And then RescueME has established a community of practice, which is a group of external experts from practice, from policy and research that get early access to our solutions. And with that, we can then get further feedback outside of the project to make the results more applicable. EU R&I Task Force on Climate Neutral and Resilient Historic Areas, where we engage with our sister projects TRIQUETRA and TETIDA, with other external stakeholders to coordinate the research efforts, the European research efforts on climate resilient heritage. And there we engage with other actors to find best practices, to define what are the scientific gaps and find common solutions to those problems.
Perfect. And last, how did the EU R&I Task Force for Climate Neutral and Resilient Historic Urban Districts get its start? How did the EU-R&I Task Force for Climate Neutral Energy? It's the same, 2 times.
No worries. So the task force started in 2021 and was founded by the Horizon 2020 projects ARC, Hyperion and Shelter, with support from the Research Executive Agency. And we then brought in other projects, other stakeholders, other actors. And all of those 3 projects, ARC, Shelter and Hyperion, ended in 2022. And the follow-up projects, so RescueME, TRIQUETRA and thematic, took up the task force and now are continuing it for the foreseeable future.
So impact chains are cause and effect models and an analytical tool that help you to understand and systemize the factors that drive a climate risk in a system. And they describe how a hazard affects a system and which other factors have a positive or negative effect on this. And in RescueME, we are looking at cultural landscapes, and we have 5 case studies, which are called R-Labs. And in each of the R-Labs, we develop 2 impact chains. And the relevant hazards that we look at in the impact chains are, for example, heat waves, landslides, changing precipitation patterns, pollution, and so on. And we do it in co-creation workshops with stakeholders. So impact chains help to understand, first of all, the factors that drive a climate risk, because you look at the question who or what is exposed, what are the impacts, so what does actually happen in my area, and also which factors affect our vulnerability. And they also enable to have entry points for adaptation measures. And another point is that they help you to understand risk from a systemic or holistic perspective, because you don't only look at one system, like for example agriculture, but at more systems and their interrelations with each other.
In RescueME, we create different types of tools and solutions that support resilience building and cultural landscapes. For example, we develop a serious game that can support with the strategy development for a certain case study, but we also have different digital tools that can show data about the cultural landscapes. And we also have for example, a measures inventory that shows you different measures for resilience building. Overall, these solutions and measures are also developed together with local stakeholders and our local partners, so we can ensure that the measures that we create are really relevant for the local communities. With the EU Research and Innovation Task Force for Climate Neutral and Resilience Historic Urban Districts, we invite also other experts, other communities and other interested people to be part of our community, meaning we share the results that we have in the project and also the insights that we get from the project. And so we can transfer the knowledge, but we can also have just discussions with other externals. So we might get additional input that is relevant for us in the project.
Okay, just for the records, your role in the project?
I'm a researcher in the RescueME project, and I'm also a work package lead of the co-creation work package.
Okay, in terms of the initiatives that we are planning in the context of BCD hubs within the next months are the on-field trainings that focus on young professionals, postgraduates of underwater archaeology, and professionals who work in SMEs. And they're going to be trained in areas such as Fourni, in the Aegean Sea, in Argosalonikos, in Aegina. And they will have the opportunity to see demonstrated blue culture technologies and to participate in trainings.
System. Specifically here in Geosystems, we have developed a knowledge-based platform which is a twofold solution, acts both as an access point for a dedicated database containing rich information derived from a thorough literature review, but also as a user-friendly WebGIS platform containing all relevant geospatial data for the selected pilot sites. In total, I can say that the knowledge-based platform, the main objective of this solution is to comprehensively integrate and visualize all the data shared by the partners, leveraging both a searchable database and a sophisticated WebGIS platform.
So process-based models are computer softwares. They are capable of solving complex physical equations such as motions or force equations. The thing is, these equations are very complex because, as you can imagine, they reproduce the physics and the nature. Therefore, they need to be solved in computers. So if you try to solve this manually, then it's going to be very, very tough and can take a few years. So this is because we need computers. I'm going to give an example that maybe is better to understand this concept. So everyone is familiar with weather forecasting, and we check every day on our phone or on TV. But not so many people knows that these forecasts are based on also process-based model. In those models, solve equations that reproduce how the atmosphere and how the Earth interact, and how for example, the clouds forms, evolve, and the precipitation, and so on. So this is an example of process-based models. In my work, I use another process-based models, and they reproduce or replicate what is happening in the ocean and in the coast, and how waves arrive to the coast, how they erode the coast, how the sediment is moving around, and so on. So this is what I use in these numerical process-based models. Another thing that I would like to highlight that as it says is as a model. So it's aimed to replicate the nature or the truth. However, it is a model, so sometimes might work and sometimes might be very close to the reality, but other time it's not that close. So you have also to be careful because those models can be or can have errors. To understand the model performance, in theta we are having partners that are collecting data. So we are going to use the data from other partners in theta to assess the goodness of our process-based model. So at the end, it's going to be a collaboration between different partners of the project, where some partners will supply data, and we are going to run the models and see how good are our models. And then our process-based model will be very important and crucial for theta, because they can predict waves, currents, or sediment transport during, for example, large storms and at the wreck. So with this information, we can assess if a given wreck is at risk, or is not, or if there is a potential damage of collapse, or so on. So therefore, this information can be very, very important. This process-based model can also be used to simulate hypothetical scenarios, for example, for climate change. We can see if for example, if we will have change in storminess and we have more energetic conditions in the future, and if it will have an impact on the wreck, for example. So this is another application of these process-based models. Even also in the theta projects, we are developing an early warning system, which is based on these process-based models. And the idea is that we will run this early warning system operationally, and if there is a big storm, they can inform stakeholders in advance in case of a potential risk on the wreck. So I think this is a very good application of the process-based model in the theta project.
Well, over the last years, remote sensing techniques, which like encompass a lot of methods, different methods, have been a game changer in monitoring cultural heritage around the globe. And this has been proven by various and a lot of scientific papers, popular science, and so on. And we like taking this further to the Arctic area, which encompasses more where the climate change effects are enhanced. Like the Arctic is warming 4 times faster than the average, than the rest of the globe, on average. And yeah, like taking this further to the Arctic, like I can say from the experience from previous projects that the use of remote sensing has we obtain like very good results, also like from monitoring perspective, but also like in preservation perspective, especially like when you want to show your results to the local authorities, like those in charge with cultural heritage management and that have the power to do something, to do some like management, to do mitigation works, which is really challenging and expensive, especially in the Arctic.
Yeah, I can imagine.
Whatever changes happen in the Arctic, like these changes will have like an effect on mid to low latitudes.
Over the years, it is quite easy to see in our regions the disappearance of coastal heritage due to sea level rise and erosion, and it provides an insight of how communities perceive these threats. So it's very recently through this project that I look more closely to the cultural heritage. I have to admit that citizens and end users are increasingly aware of the challenges of these problems in the region, mostly for coastal heritage, mostly due also to urbanization, excessive tourism, environmental challenges, and all those are exacerbated with climate change. So it is indeed for the region quite easy for this part of the coastal part. However, understanding the perception of threats to underwater cultural heritage is more complicated and nuanced. We have different kind of end users. Of course, divers who often engage with underwater sites tend to appreciate the need of conservation efforts, while if you go to other type of end users, such as fishermen, they will be more afraid that it will imply limits to their work. So it's not so easy to get there. So the end users are very wide in spectrum, and their interest and natural belief in conservation and monitoring of underwater cultural heritage is very different. There are several challenges. The 2 main ones will be indeed the lack of knowledge of underwater cultural heritage. So only a very few people, the divers mainly, and people from the cultural departments will have this awareness of cultural underwater cultural heritage. So there is a lack in general of awareness among many end users and stakeholders of these assets. So that's the first main challenge is how to transmit this information. So just the fact that they exist, and the second one is that they are under pressure due to climate change. So those are two different. But there is also a barrier or challenge linked to the engagement and cooperation among the different end users. And we realized that these different end users usually do not speak together, so we have to put them together. And this is another problem, is that putting together, for instance, people working in tourism and fishermen, it's the right moment to find a common moment to do that, because we are in a very touristic region, as I already said, and the low season is very short. So outside the low season, people from tourism, divers, they are always very busy, and the schedule is not easy. And if we want to link them to fishermen, then there is also the time fishermen pass on sea, which are linked to the tides. So mostly when they are free, it's outside our hours too, because the tides do not take care of business hours, and this is another challenge. And of course, working in the sea is a very tiring job, and they are not so available to be in this type of engagement outside the hours. So it is a problem, but there are now several associations that represent fishermen or aquaculture or people that live from the sea, have their economic lives linked to the sea. And through these associations, it's easier to get information and to have these moments of sharing and working together. So I think this scheduling with association and entities is either when we want to do it. There is another challenge that we also saw, is that somehow there are some information already existing, but very diverse and in several places. So the first interesting part was to see that people have information, but it was not shared. So the fact that we want to try to have this sharing information, that's another challenge, because people are not used to share. They are always afraid that it will be used for something that is not in their own profit. And so this is also an important step to try to convince that is for a better, that they have to share information and what they need. One of the primary outcomes working in this new area is indeed to facilitate the collaboration among very different groups. And this allows fostering dialogue and knowledge, exchange of data, as I just said, exchange of information. And as you know, this is the first step for good management, and having a strategy for the management is knowing what it is indeed on the field and what we know about it. So this first part was very interesting. So we can have a comprehensive database of the documentation, of the region's cultural heritage, underwater and coastal, but mostly underwater in this case. So that was very effective. And more than that, we even managed to have a power to bring in even association or groups that are not from the region. When they heard about this working group and this initiative, we had people from the rest of the country, which would work in the region or come for holidays. So some divers and some researchers that joined the group. And this is also a big win, because we managed to reach other people and work together. So this is the first step. Then when we want to speak about this effort for an effective management strategy, the understanding of the existing cultural is not enough, and we also have to address the preservation and thus the acquisition of more information, or having a survey, a constant survey. And these living labs, or this project, helped us to start a planning, to have new moments of survey, to understand how we can work together, so the effort is not always on the same group. We can have several groups at different moments doing the effort of monitoring or doing the survey of the cultural heritage. So that was also very interesting, because it allows to have an interdisciplinary approach with different views, and it also attracts people from outside the region. So that was a second very interesting experience or result. And finally, I will say that among the end users and the stakeholders, it is also very crucial to engage the community in general, and to have this awareness regarding the threats that underwater and coastal heritage face, mainly regarding the climate change. And so the role of the museums and science centers are also very important in developing activities, so that people get aware of the existence of this cultural heritage, and get also aware of how the changes, environmental changes, climate changes, are affecting this cultural heritage. So having some educational programs and some activities in which the citizen can participate and have this information is very important. It allows to mobilize both the expertise and the public support to some local initiatives, and have this work together in the community. So I will say that this is another level that was seen that was very important, working with schools and having also this opinion and this knowledge spreading around the community.